Hello. Hello. Okay, so hey everyone, we are going to start day 5. Yeah, so this is day 5 of building LLM from scratch using ROS, and as always, the rules will be no AI. So yeah, it is interesting and it is cool to have. Okay, we're starting live stream. Okay, yeah, so we are going to do day 5 of building LLM from scratch in ROS with no experience, and let me show you what we did so far. So the first thing is that we are working in this main file, and we will able to import a file that has a bunch of text, and from those texts we were able to import it into our ROS program, and then we count the number of characters, and also we were able to slice and doing the converting to string using regular expressions, and from those regular expressions trim the the sentence or the list of strings that we have. Then we pass it into a vector of strings, and those vector of string we are able to count, which will be the number of tokens. And as you can see, we prepare the data to have a vocabulary. One thing that we need, that we learn in day 4, is that we wanted to have unique values, and those unique values in an LLM means the vocabulary size, or all the vocabulary that we're going to have to train the model. So there are many things that we can do here for building the vocabulary, or building the body of knowledge that your LLM will is going to have. And also we iterate over each of these elements, and we map into a tuple. So let me show you what we have so far. So cargo around, which is the command that we learn. And yeah, I mean, let's turn this off because we don't want to the AI help us that much. So yeah, as you can see, these are the token IDs. So we are able to put the token IDs here, and those token IDs is what we map, which is each value. Let me show you how it works, because Sebastian, we're following Sebastian Rashka book. It's a great book, you should get it. But he has a GitHub repository where all the information is there for free. So we are still doing in chapter 4, and we are at this stage with which is data preparation. And from those there, yeah, so we did the same, like we kind of translate to RAWs, learning things on the way. And we are exactly at, okay, we already passed it, we are exactly at this stage. There are some small difference that we have between our approach and this model approach, or RAWs approach. But yeah, I mean, we don't need to spend a lot of time on that. We just, can just work with what we have. So yeah, so this is the vocabulary. This is the vocabulary that we want. So we iterate over each element. Okay. So what do what do I want to do? So what I want is to iterate over these elements and store them into a vocabulary, and then I can do something like this, right? The first 50. Okay, so what do I need to ask? I need to ask how to store the outputs of a loop in ROS. Okay, how do I store the output of a loop in ROS? ROS. Yeah. Okay, so yeah, we have Stack Overflow. Stack Overflow is really great. Also, we have the ROS programming language. Sounds great. And ready, I love ready answers. I don't know why, but I love it. Yeah, just one more, just in case. Okay, so here best practice for returning values from for loops. Okay, we have a question that is similar to what we want 5 years ago. I'm new to Ross. I'm finished reading chapter one of the Purple Crab book, and I'm stuck. I'm using this grad for okay. I want to return the output of and finalize. How do I achieve this in Rust? In Python, I do something like yeah, but I don't know if I wanted to go to this path because it seems like a lot, and this is not how we even do it in Python. Maybe we have something like this. Okay, how to return value from for loop. This makes more sense, more similar to what I want, right? Why the above code is giving me an error where I'm clearly returning I do type from for loop. Since for is not statically known to be infinite loop and the interior is looping over might be empty. It is not guaranteed that either the control flow reaches the break unconditionally or it loops forever. You probably want a loop instead of for. Hmm. I don't know if that makes sense to me. Honestly, I have no idea if that makes sense to me. Let me see. Story generators in a vec and looping through them. Is there a way to store generators in a vector and then loop through them? Can't seem to get the following to work regardless of my boxes and pins. It is crazy how people used to ask a lot of things in online. That's how you debug yourself, and now you have AI to do everything for you. Yeah, I don't know. Let me see. Hello, Rust community. As an exercise in learning Rust, I'm trying to make simple console program. I should be able to acquire data, store and modify it by user command. I have run into troubles with the second part. Somehow, when trying to store user input, I'm running into borrowed values do not live long enough error. Below is a program snip that reproduces the problem. Yeah, but he like this is trying to store in user input in the loop, and I don't want that. So maybe we can know, right? Yeah, I don't even know that this exists. What's the difference between loop and for in Rust? Okay, really hard for loop iteration. I don't really know what's the difference between the loop. Like it seems that you have a curly bracket which have it everything inside and iterate, but I don't really know what's the difference between the loop and the for loop. No idea. So for loop iteration difference, it's really hard time for me to understand the difference between iterating through a vector in Rust programming. Alright, okay, I'm able to change the elements and access with index, very comfortable using this. For E, not sure when to use this. For E, okay. Yeah, but I think I'm talking about the loop in curly brackets. I don't know. Let me see if I can find something here. Okay, control flow, expressions, functions. Rust provides a loop keyword to indicate an infinite loop. So it might be like a while loop, right? But we also have a while. Okay, now yeah, now that's confusing. Okay, but Rust provides a loop keyword indicating an infinite loop. The break statement can be used to exit a loop at any time. Okay, whereas the continue statement can be used to skip the rest of the iteration and start a new one. Interesting. Okay, okay. So, okay, we have infinite loop. Okay, so this is infinite loop. Running loop count, okay. If count equal to 3 is 3, okay. Continue, skip the rest of the iteration. Okay, that's enough. Okay, so that X is the break. Okay, so here we are returning from loops. So one of the uses of a loop is retry an operation until it succeeds. If the operation returns a value, though, you might need to pass it to the rest of the code, put it after the break, and it will be returned from the loop expression. No idea what this means, but from what I'm seeing here is that we start with the counter, then the counter, then we define a variable which will be called result. Then we have the loop in curly brackets. We have the counter that adds 1 at every iteration. So if counter equal to 10, break the counter, break counter by 2, right? So equal. Okay, I no idea. Okay, let me see this. For loops, for and range. The for in construct can be used to iterate through an iterator. Yeah, an iterator will be like a vector, right? One of the easiest way to create an iterator is to use the range notation a, b. This uses a value from a inclusive to b exclusive in step of 1. That's why it fits boost using for instead of while. Okay, so what I'm saying here, yeah, it's similar to what I did, right? But this is a tuple, I hope, right? For if n equals, okay, yeah, it should be return something, right? Yeah. Okay, now I know. Yeah, so this is a bunch of print. Mm, yeah, now we're talking because this is what I need. Okay, so we have a vector of names. Yeah, I have a vectors of word. Okay, and I have a name, an iterator, match name. There is restriction among us and print hello name. Yeah, yeah, but the vector is already there, right? I don't know. So we are not changing the vector, right? Okay, so if I would be doing, okay, let's just use logic. I will be collect modes. How Sebastian called? Vocab. Okay, vocab will be equal to, how do I define a dictionary? I will say the same as Python. I don't know. Really, I don't know. Okay, perhaps. No idea. Let's see if this can help. I mean, yes, but I wanted to store in a dictionary. Okay, so I think I have a better question to ask. So how to store values in a dictionary in ROS? Okay, so yeah, I want to see this because this is big. Yeah, I mean, I don't know. Let's go to the documentation first, and then if we can, we will try to do it. Okay, so okay, I was on the right track, but I missed this. We already defined a hash map, right? Yeah, yeah, we already. Oh no, yeah, we haven't defined, but we can define the hash map because on, yeah, I know it is because that was the example, but we remove it because we wasn't using it anywhere, but now we do, right? So this is what initialize the hash map, which is the dictionary. So then I use this insert. Okay, will be, I don't know if it is string. I think it's str. I'm not sure. Let's see the error message. I think this will throw an error from from okay, let's go to the Ross playground. Yeah, that's what I want. Let's put it here. Yeah, and I mean, we already had an example from last week, but I didn't know. Yeah. Okay, so it is insert to string. Okay, from, I mean, yeah, but I think we can use n, and the other one would be top. Is that good? Okay, let's see. This will throw an error. Yeah, it did throw an error. So the tray is not implemented for string. Yeah, I think I'm pretty sure it's this one. Okay. Yeah, maybe I should do this. Let's try again. Okay, so it says that the size for values of type string cannot be not a compile term. Okay, but you say that string doesn't work either, right? Oh, yeah, so this is W and this is N because I'm inverting them. Yeah, let's put string here, hoping that this working. Oh, no, it's not working. Maybe this can work. Yeah, maybe this is an old thing because the answer was, yeah, the answer was all. Hmm. Yeah, but I mean this is actually working. Yeah. Okay, so let me try to explain the problem that we have here. So what we want to do here is we want to create a dictionary or a hash map, and from the vocabulary that we already have, we want to iterate over each element of the vocabulary, and we want to store with a key value pair. So now with that, every word of the vocabulary will have an ID, and that ID is that we can use for passing through the tokenizer and then making the LLM learn. So this is a critical step. I mean, there are some nuances that we can learn from here, but this is a critical step and we need to do correctly. The other thing is, or what is failing here is that I want to pass, I think W is the word and N is the ID. So I already defined the hash map, and the insert keyword is what is how you insert something. But yeah, for some reason it's not working. And how about if we put just W and N? Will that work? Oh, it did work. How about if we don't print and we print L L. Okay, so it is print. Is that what we? Okay, LN. Yeah, I think that's what we use. Okay, so yeah, but may it looks like this work. Let me check this out. It looks like this work, but yeah, it looks like this work, but I need to iterate to just make sure. So maybe for key value in. Okay, according to this documentation, this should work. But yeah, it's not scores, it's vocab. So this should work, right? Nope, didn't work. Oh yeah, yeah. I always mess up with this letter. Okay, it does work. Okay, let's wrap it up. What we did. So what we are trying to, or one thing that we need to keep in mind with ROAS is that we do need to define everything that we do here. And let me explain. The goal is to create a dictionary based on all words that we have in our file and map into an ID. So what we did, we started for defining a hash map, which is the equivalent to be a dictionary in Python. Then we use this keyword, the iter and the enumerate keyword, to iterate over each element of the vocabulary that we of the all words that we have. And from defining all the words that we have, we were able to insert the word with a number. And after we have the word and the number with this vocab insert method, we were able to store it and then print it successfully. So every item of the list, it has a number associated, which will be the ID, which will we are one step closer of having our tokenizer. So that's pretty cool, right? Pretty cool that we were able to do this that fast. I was about to give up using trying to using AI, but we didn't have to. We figured things out. Really intuitive. So yeah, let me. Okay, so yeah, we already have this. What do we want to do now? So Sebastian, what he did here is that he iterate over each element, but he only used the the first 50 vocabulary or words that we have or elements that we have in our vocabulary. So maybe it's time to check back some control flow. Yeah, yeah. And what I want to actually do is to having a break a break operator, which I think is possible, and perhaps we can see it in while loops. Yeah, because while loops are infinitive, so you do need to have it. Yeah, but we don't have it here. Yeah, so what I want to, okay, so yeah, you use break the same way. So, okay, let's put it if, Sebastian did it. He put number I, yeah, because that's if value, yeah, I think value is a break candidate is equal to 50. I want to break, right? Okay, so first I print, then I break, right? Where are we? Where are we? Where are we? I think below. Okay, yeah, this loop. If count equal to 5, okay, curly brackets again, break. Will this work? Who bet on me? Let's see this working. Hope this work. Hmm. Okay, so let's try to learn here. Can compare usize with integer. Oh, help the try. Okay, it's not implemented for size. Help consider reference here. Okay, so what Ross compiler suggests I put this and this will solve the problem, right? Okay. Yeah, but one thing that I don't understand, maybe this is not order, right? Maybe we didn't sort this out because this sort is not returning anything. And how about, can we put this sort here? And that will do the work. Let me see. Let me see if that works. Yeah, no, that doesn't work. Let equal to that sort. Is that possible? Is that possible, guys? No. Yeah, this work, but this is, so the problem that we are having here is that we don't have a node or element. So I did this sort, but I realized that this really doesn't have any. Yeah, so I'm not doing anything basically here. Yeah, but maybe if I put sort here, right? Or yeah, that, maybe if I put sort, then either, maybe that work. Okay, so I cannot do this right here. And it looks like I cannot define, but maybe if I do this, maybe that does work. Yeah, it doesn't work. Or yeah, maybe I can do this so I cannot break, I don't break anything. Yeah, I mean, so I didn't sort, but how do I, or what's the output of sort? Does anyone know? I mean, yeah, I have no idea. Okay, let me think. Now what? Let's just give me a minute. I will be back. Just a minute. Hello there, I'm back. Yeah, yeah, better ideas. Okay, okay, guys. So let's try to think this through to see what's the issue. So I have the vocabulary, but it's not sorted. So I do want to sort it. And the what we did try here is with iterate over each element, but I don't know, for some reason this sort doesn't work. Or I mean, it does work, but it's not the same. Okay, perhaps let's look how to sort a hash map, a vector. How to sort a vector in Rust. Let's see, we have it here. Yeah, but that's okay. So how to sort a vector in Rust. Okay, let's see. What is the current increment method for sorting values in a vector? A movable slice of elements, a total already has a sort method. So vector works. What are the requirements for t-type? I'm getting error that says does not the type implement. There is a sort by method too, which allows a completely custom predictability. As the doc said, self-doc, self-sort. To sort a vector in most cases, sort will be what you need. If you want to apply a custom order, you can do through sort by that includes, okay, yeah. Yeah, but I mean, that's not what really what what I want. What I want is to see what's the return, because here it seems that I can apply it, but I cannot see it. So it's sorted in a way that it's sorted, but I cannot get the values from it. So I mean, sort, yeah. Oh no, yeah. This is a different. Okay, let's see this cookbook. Okay, okay. But is this in place operation? Is that what you're saying? Is that in place operation? I, I don't know, man. I mean, it doesn't feel like it because everything changed after I do this, but it seems like it is a in place operation. So if I do this, he's telling me that this work, but I don't believe it because okay, let's see. This is a backup size. That's what I mean because we have the insert key values, backup key values, iterate and enumerate. So I don't really know what's going on because based on what I'm seeing here, sort is a in place operation because yeah, I mean we are testing this out, and then we are testing here, and it works, doesn't show anything. And this the same. But I don't know, I mean, for me it doesn't seem like in place operation, you know, because I mean, look at this. So let's think about what's the issue. Let's see how this iterates. It does seems like it iterates in order, right? But maybe this sort, it doesn't sort strings. You know what I mean? So what happened here? I defining a vector where I store all these values, and these values are then sorted, and then so if I sort this value will be all, then John, then Zoe, and that's exactly what we are having here. So it does work for words. It does. Maybe I'm messing things up here at this stage. Could it be? Hmm. How can we debug ourselves from this? It's an AI. Yeah, let's try. Yeah, but I don't think here is the issue. So this is okay, this is okay, this is okay. Maybe this is not okay, right? Maybe there is a discrepancy in here. Yeah, but I don't understand. Okay, so what do I want to ask? Check this code and tell me if why is not printing in order. Don't apply, just tell me. Okay, yeah, so yeah, I was spending a lot of time trying to debug this, and doesn't seem that is a too much of a problem, but yeah, there is something that I ignore from this that is too difficult for me to find, you know, without any background. So yeah, I had to ask the AI for help. Yeah, but I know what do I want, and what I'm looking for. So the reason the code is not printing order at the end of the file is due to how behaves in Rust. Hash map is on order. Okay. So the vocab variable is a hash map. A standard hash map in Rust do not preserve insertion order. I didn't know this, or guarantee any specific iteration order. Okay. So the problem is with the hash map. Yeah, we were able to identify the order is determined by the hash values of the keys and the hash map internal bucket layout, which is randomized by default to protect against hash collision attacks. Okay, this is pretty advanced, right? Arbitrary break condition, because the iteration order of the hash map is arbitrary. The condition if value equals 50 break, we triggered at unpredictable point in the loop rather than after the first 50 sorted elements. How to fix it conceptually? If you want to print the index in a specific order, you can iterate over instead of seeing. Okay, since it's a sorted vector, you can slice and print it directly. Use B-tree map if you replace hash map from collections, the key values will automatically be sorted in a certain order. Collect the entries of the hash map in a vector and sort them before printing. Yeah, but I have the vocabulary and I do, yeah, yes, but oh, yes, yeah. I mean, I know what he's saying. So let me show you. What is happening is that in Python, this vocabulary does preserve the orders in which the words and the IDs are added, right? So that's why you can do this and it will print in order. You can see this, right? But in Rust, you do have the access to vocabulary, but if you wanted to access to something specific in the dictionary, you just need to call the key value pair. But when you print all the values, won't you won't have the sorted elements because that's not possible in Rust. Rust store everything on the hash map and the order doesn't matter, and they have protections against doing that because something about the hash does. But the important part is that this is how it is stored. But it's giving me something that we can use. Use B-tree map. If you replace hash map with B-tree map from standard collection, the keys will be automatically be sorted in ascending order. I mean that makes sense, and we can try. I mean, we can do it. It's really not a big deal, and I think we can learn something if we use this B-tree instead of the hash map, and let's see if that works. But it wasn't something that we were doing wrong. Okay, great, we got it. Yeah, but let me fix this real quick. I don't want to have this out. So let's run it again. Let's put clear. Amazing, guys. We were able to put this together. Yeah, and now I know that the difference is in this, in the first 10, because what we have is, yeah, we just store a handful of value, but we don't store the full stuff. And I don't think that's good, but yeah, it seems not that much, right? But maybe it's because when we iterate and we enumerate, it's not storing in the same place. I don't know if this makes sense. Yeah, because but it seems like it, right? Or maybe we can just put this out. And see the full picture. Okay. Yeah, let's try to recap what we did. So instead of, the problem is the hash map. I mean, the problem is the hash map doesn't store in order. So whenever you insert elements to the hash map, it doesn't care the moment that you put it there. It's just care that it's there and it has a key value pair. So that's why when we print out every element of the vocabulary, it wasn't printed in the order that we store it. And setting to 50 value to break was a random indication, because you can have, at any place it can be 50. So it doesn't really did anything. So what we did is, instead of using a hash map, you can use a B-tree map, which does store the key value pairs in the order that you put it. So this is closer to what a dictionary does in Python. So I think it's pretty cool to have it here. And yeah, I mean, we do have discrepancies between what we are doing and what we have, but I don't know. I don't see that the difference are too big for concern right now, because the difference are really small. Although there are some things that yeah, it really got my attention. Yeah, I mean, because whenever I run cargo run and we see it, this is what concerns me the most. The total tokens, I think, is pretty similar, but we do have some discrepancies, like 80. And yeah, the length, the vocabulary size is 1130, while we have 1158. So we have more vocabulary size than tokens. So yeah, I'm not happy about it. Then when we print it, we see that we don't have that many of these stuff. I don't know if it is by design or something, but yeah, it is what it is. And yeah, the 50 element is with the S, while this is Hermia. So yeah, small difference. I don't want to be bothered for that much, but yeah. So let's continue a bit, and then we move on and we wrap it up. So below we illustrate the tokenization of a short sample text using a small vocabulary. The tokenization breaks down the training set into individual tokens. So we have the sample text, and then we have the tokenized sample text. And the difference is that you have the sample text, or whatever text you have, and then you split out and you map with the ID. So that's the tokenized sample text. And new tokenized sample text is mapped to token ID, which we did with the B-tree map instead of the hash map, because we already know the reason why in ROS. So using a system vocabulary, token IDs. Okay, yeah. So next time you have a sample text, it will use the token IDs that there is already defined for that text that you have. So yeah, I mean, we are going to start with the tokenization part of the program. So I'm pretty excited about this, right? Because okay, I don't know if in ROS you can define a class, but let's try to understand. So we have the simple tokenizer B1, which is defined as a class, and then we have the initialize method, which we have self, and then we have the vocabulary, and that vocabulary will be into, yeah, this is pretty standard what we did, because you map the vocabulary to the IDs, right? You create IDs. String to integer, integer to string. So here we iterate over each element. Okay, we iterate over each element, and we store. This is the integer, which will be the ID, and this will be the string or the word. Then we encode using this regular expression. Then we decode. The encode function turns text into token ID. The decode function turns token ID back into text. Let's see if can we define class in Rust like in Python. No, Rust does not have a class keyword and does not support traditional object-oriented classes like Python. Instead, Rust decouples the data from behavior by using structs to hold data. And okay, maybe we need to check structs in Rust. Yeah, similar word, defining an extension. Okay, I love this. Okay, we are going to learn structs in Rust. So structs are similar to tuple, discussed in the tuple type section, in that both hold multiple related values, like tuples. The pieces of a struct can be different types. Unlike with tuples, in a struct you will name each piece of data so it's clear what the values mean. Adding these names mean that structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the values of an instance. To define a struct, we enter the keyword struct and name the entire struct. Okay, yeah, it seems like this will take me some time. So yeah, let's recap and we can split this out for the next session. I really love that we were able to reproduce the first part of Sebastian Rashka's book. And to summarize what we did, we already had the vocabulary size and even the vocabulary, we already have it. But what we need to do is to map this vocabulary to the token ID. And that token ID for now is selected just based on the position of the word. So the first word in our vocabulary will be 0 and so on. So the important part to have this is that you need to have some number to represent the word, and that number needs to be unique. So you don't need to have, you won't have two zeros or two ones. You will only have a unique ID for each of the words, and that's what we use to define or to pass as a tokenizer. So we already have that in place. We already defined our B-tree map, which in this case works perfectly and imitates a Python dictionary at its core. So that's very convenient for us to see the similar behavior to what Sebastian did. So for the next session, we are going to implement our struct tokenizer, which would be pretty cool to see it, because now we are entering into the field of AI, and previously we were only using the field of handling data and manipulating data and see how to turn raw data into something that is useful for the tokenizers. So yeah, thank you so much, guys, and please remember to subscribe so we can chat on and see this live. So yeah, see you in day 6. Bye.